Hi everybody, today we're going to prove the Pythagorean Theorem, and I'm going to show you one way to prove that. And the way we're going to start is by drawing a rectangle. A square. The square has length side by side, and therefore the area of the big square is side squared. So we start with that. Next thing we're going to do is actually draw triangles inside of the square. And I'm not the best at drawing these things. Let's see. Not too bad. Okay. That's actually terrible. Let me erase that. Erase. We are just going to move that guy a little bit. Let's try that again. That looks better. Anyway, we take our big square and we realize that we can calculate the area as the side squared of the big total square, right? But actually, we can break this up into pieces and calculate the area of the pieces and add it up, and we should get the same answer. And so what I'm saying is we have 4 triangles, right? We have 1, 2, 3, 4 triangles. And so we should be able to write 4 times the area of the triangle plus 1 times the area of the inner square. And the inner square is the shape right here in the middle. This right here is the inner square, this shape here. So let's give some letters to this. So these triangles are going to have a base of A, and a height of B. A, B, A, B, A, B. And so basically the long side of the triangle is A, and the short side is B, essentially. And we're going to call the diagonal of each triangle just the same C. They're all the same triangle. And essentially what we're doing is we're saying, well, the side is just A plus B. So this is A plus B squared. That's what the side is. And we do 4 times the area of a triangle. Well, the area of a triangle is 1/2 base times height. And in our case, the base is A and the height is B, or vice versa. Doesn't matter. We have 1/2 A times B and 4 of them. And then we have the area of the inner circle. Well, the inner square. The inner square is just side squared. The side length is C. So this is C squared. If we expand out these terms now, we expand the square. A squared plus 2AB plus B squared. That's going to equal, well, the 2 cancels here. You get a 2, so it's 2AB plus C squared. Now you can subtract the 2AB from both sides, and you're left with A squared plus B squared equals C squared. And that's our Pythagorean theorem. And this really hinges on the fact that the shape in the middle is indeed a square. And the way to show that the shape in the middle is indeed a square is by, let's give some letters here. So let's call this angle X and this angle Y. Okay. Well, we know that this is a right angle. And so we already know that the sum of the angles inside a triangle should be 180. 180 degrees should equal, well, the right angle, which is 90 degrees, plus X plus Y. And this equation simply says that 90 degrees is X plus Y. So we have that as one equation. Now, if we look at this over here, this whole arc length should be 180 degrees. Okay. Well, if that's 180 degrees, and we know that this is X here, then this angle over here, well, we know the angle between C and B is Y. So this is Y, and therefore this is a right angle, and this is X. Sorry, I said that wrong. The angle between C and B is Y, and so C and B over here is Y. I said that backwards. This is actually inverted. So like I said again, let me reiterate that. The angle between C and B right here, C and B is Y, right? And so C and B is Y here, and therefore the angle between C and A is x, and that's here. C and A. Here's C, here's A. There you go. And so this 180 degrees in red is actually, this 180 degrees in red is actually your x plus, well, I don't know what that is, question mark, plus y. And I know that x plus y is 90, and so this is 90 plus question mark. And so therefore, it's easy to see that minus 90 minus 90, we end up with question mark is equal to 90 degrees. And so this is a right angle, and you could do the same thing at every corner. They're all right angles. And that means that the shape in the middle is a square because every inner angle is 90 degrees and the shape, the length of the side is always C. So that validates the fact that the inner shape is indeed a square, and that means we can calculate the area as the sum of the pieces, and lo and behold, we end up with the Pythagorean theorem. So hopefully you guys enjoyed that. Just a little quick fun video on how to calculate, well, how to derive the Pythagorean theorem. And I'll see you next time.